And Lord, I just ask for just prayer over them as they go to college, and then also as they decide what college to go to. Just give them favor for the schools that they apply to in that way. Lord, I think that I may have gotten everything. I probably forgot something. But Lord, I just ask for blessings and strength through the day, through this week, and be with the senioritis, because we know that that's a real sickness. That can be something tough to come by. And so, Lord, just help us as we continue forward. In your name we pray, amen. Okay, cool. Let's do this. Let's go straight into the lesson, okay? Here's what I'd like for you to do to start us off. Part D, I want you just to kind of circle that one, because you're going to have to come back to that. You're not old enough quite yet to get to that, but by the end of today you will be. On A, B, and C, on for A, B, and C, I want you to go ahead and try to navigate through these. Now, to kind of start us off, maybe this will help you. I'm going to, if I can't solve this, set it equal to x. So if I had log base 5 of 1 over 125, I would like for you to set that equal to x, and if you don't know how to simplify, what can we always do with a log? Exponential. Very good, Zari. Yeah, let's change it to exponential form. By shooting what over? Shooting the 5 over to the other side. Good. And once I do that, shoot the 5 over to the other side. We'll do the first one together just because I think, just to fly through here. We would get 5 to the x power equals 1 over 125. Can anyone else tell me what I could do, Thomas, to simplify?
You could turn the 125 into 5 to negative 3.
Yeah, so this 125, and just in case you can't make that jump, 1 over 125, we could turn into 125 to the negative first. And then 125, we could say that would be 5 to what power? Good, yeah, so this would be 5 to the, in total, negative 3, right? Well, if 5 to the negative third goes where 125 is, what can I do once the bases are alike? We could cancel those out. Good, so, and I know they're on separate sides, but the 5 and the 5 would cancel out, where x would be equal to what? Negative 3, and that would be my answer for this specific problem. Do y'all remember this a little bit? Kind of a little bit of a review. I want you to go through B and C. Try it out. See if you can simplify it, and then we'll move forward, okay? So I'll give you just like maybe 2 minutes. Try to go through it, and then we'll go on to the other parts that are here. Again, hold off on D. You won't get to that yet until kind of later on, all right? Take it, Ken. This homework will be due on Thursday, though I anticipate some of you may finish today or have maybe 1, 2 problems left. The majority of it today. But Thursday is the official kind of deadline. Throw attendance down. When you're done with 2, I'd love to check and just make sure. See how we're doing.
If it's 3 to the 4th, I still have
81
went to 2, right?
3 to what power?
Then you would cancel out every use, and then it would just be x equals.
4
You would just leave it.
times.
Yeah, you just leave it
Good. And then once I do that, you'll multiply 4 times what? Well, yes, now let's say this. x, right? Because that stays the same. But for 81, you plug in 3 to the 4th. Does that make sense? You can, because we canceled here, I love it, but that would just be 4, the exponent kind of goes away, right there, and then it would be 4 times 3, which would be 12. Yeah, exactly. Good. That's a good question. So that's one we're going to look at. The ln of e to the 4th would be like, that actually cancels ln of e. And it just leaves us with 4. It'd actually be 3 times 4. Just 3, because and you'll see in a second when I show it, because the exponent would actually go away in that instance when you cancel that out. It's good. Did y'all get that second one? You didn't get that second one? Oh, I'm sorry. So you mean the third one? Or sorry, yeah, well, the second one. You're right. Yeah, the second one, or C, that one's a little tough. Did everyone get B? Are we good on that? It should be what? What was the answer? Negative 0.8. Very good. I will tell you, C was one we did yesterday. I want to make sure we can kind of review on this. We had the value of, oh, it's frozen, my fault. There we go. There we are. 3 ln of e to the 4th. Question, what is the base of ln if we don't know? E. Yeah, good, Thomas. And someone other than Thomas helped me. What would I do from this perspective when I have the base and value as the same thing? What could we could cancel, we could cross them off. And when I do that, here's the one thing people mess up on. When I cancel this, what's left over on the right side? Just a 4, right? So the exponent almost like goes away to where I only have 4 times 3, which gets me 12, and that would be my answer there, okay? Did that make sense? Let me ask, did anybody that did not make sense to? We're good? Is it hot in here? No, it isn't? Okay. I'm going to do this. I'll probably just, okay, good. Pump it down 1 just a little. Okay. D we're going to come back to, and we're going to hit that here in just a second, okay? All right, there's 2 types of things in this lesson. The first one's really, really easy, okay? It's like I call them quick hitters. Go to numbers 1 and 2, okay? Right at the top of your homework, you're going to notice it says something about the change of base formula, okay? Change of base formula. All right, this idea of change of base allows me to simplify a log if I can't simplify just by our simple means. So like for instance, if I had log base 3 of 3, what would that equal? 1, right? We know that. It would equal 1. And we'd be good to go, right? However, what happens if I have log base 3 of 7? Can I simplify that? No, yeah. What would we do, Caleb? Yeah, so we have x here. So what do we do? Yep, right. Who did that? I love it. Good, Josh. Yeah, very good. Whoop, over there, right? Have I ever done that one? No? It's my victory trumpet? No? It's really weird. I'm sorry. It's a new thing, so I apologize. If you feel uncomfortable, I just saw your faces. You felt uncomfortable. I apologize, all right? So we put it over here, and we have 3 to the x equals 7. When we whoop on the other side, question, 3 to the x equals 7. Can I simplify that? What's the problem? Yeah, 3 and 7, we can't get 1 to 1, right? We can't get them to where they're the same base. So because of that, we actually back up and we do something a little bit different. We call it the change of base formula. And by the way, this would be using a calculator. So we could use a calculator for this. We could do it one of 2 ways. Way 1 is we could actually take the log of the outside over the log of the base. So this would be like log of 7 over log of 3. Okay? It's called change of base formula. The log would be applied to both. So if I were to do this on an actual calculator, I would actually just go into this and say, okay, what is the log? I'll literally put log of 7, press enter, divided by the log of, what was it, 4 did I say? 3. Log of 3. And when I divide that, the answer is 1.77, okay? Again, called the change of base formula. Another way I could do this, same answer, okay? The second way I can do it is also by doing the ln of it. So ln of 7 over ln of 3. It would still get me 1.77. We're just using a different type of log, okay? Now, question. Can anybody tell me what I call the log log? And it's called a log, but what specific type of log? Raise your hand and help me with that if you know. Elijah, do you know? Great job, my man. Common log. Very good. And what would be the ln of that? Natural log. Very good. I'll tell you what, that's a good one. My other classes haven't gotten that yet. One right there. Good work. Nicely done. Good. So we call it the natural log right here, and this one's the common log. All right? Both would produce the same answer. This formula is called the what? Change of base formula. Yeah, change of base formula. And this one's using the common log. This one's using natural log. Pretty simple. Okay? So, like, look right here. I think there's one of these on our homework. I think it is this one right here, number 4. So as we do it, real quick, someone just throw it out there. If I say use the change of base formula to simplify, and I was saying use natural log, what would you give it to me as? Good. ln of x over ln of 1/3. Good, Caitlin. Someone else give me what it would be in the common log. That's it. It's just log of x over log of 1/3. And it would be for both ln, so the natural log and the common log. Okay? Good stuff here. Questions on this?
Is that all we have to put?
That's it. Why can't I plug that in my calculator? Because there's an x, right? So really that one is just simply writing it out. On number 2, you're doing the same thing, but that one you can actually plug it in your calculator. Okay? Easy. Piece of cake there. Number 3. Ooh, yes. Number 3 is a little tougher. That's going into our third topic. Okay? Or I say second topic. And we're going to go into it this way. I will tell you, this is the part that you're going to be tested on more than the change of base formula. Okay? So this one's very, very important. Okay? Numbers 1 and 2 on the homework. Y'all good on that? Did y'all finish them? Okay, good. Let's go to this next one. The next one is one you really want to tune in for. I'm not going to talk very long through this. It's going to be more practice, but the part I do talk through is a little bit important. Okay? First off, the rules apply for both the common log, like Elijah said, and the natural log, like Kennedy helped us with. Okay? Both rules apply for each. Okay? We have 3 rules. We have what's called the product rule, the difference rule, and the exponential rule. Okay? All right, so the product, well, I would say the addition, the difference, and the exponent. Okay? All right, so let's look at this. The first rule is this. We can go back and forth between these rules. So if I go into one where I kind of expand it or I make it larger, going from the smaller version to the larger version, this is called expand. Okay? If I go from the larger version, which is the right side, to the more simple version, y'all know what this is called? Condense. Very good. Good work, Thomas. So we expand, and then we can also condense. So as we go back and forth, that's really being able to do both is important. So let's talk about the first thing. If we were to expand and 2 things multiply side by side in a log, we can expand it by breaking it up with a addition symbol. You say, Coach, what do you mean? Well, let's say I had log of 3x. How can I expand that? I could put a 10. It's understood, but you could put that there. That's fine. So they're multiplied, right? If I were to make it larger, because they're multiplied, we separate them with a an addition symbol, right? So this would be log, and I'll put the 10 in, but you don't have to. Log base 10 of 3, then what? Plus log base 10 of x. We expand it, we make it larger, right? And if I went from here to this side, we would be condensing it, okay? So going back and forth, make sure we know how to do that. The second one is if we divide them, u over v, and we divide them, let's say we had log base 10 of 3 divided by x. Someone help me, what would we do with this one to be able to break this one down to expand this one? Good, and it would be exactly that. So it'd be log base 10 of 3 minus log base 10 of x. Now, do I have to put the 10 in there? I don't have to because it's kind of understood. Now, if it's anything else for earlier, if it's anything other than 10, let's say it was 7 or x or something like that, you'll need to put that in there, right? But 10 is understood as that, okay? So division would be broken out or expanded with the subtraction. Multiplication is the addition. There's only one more, okay? And that's what's called the exponential, okay? So we'll do the exponent. Is everyone good on these two? We're good here? Okay. So the exponent one says this. If we have log base 10 of 3, let me actually backtrack. I'm going to do this a little bit different. Of x to the third power. X to the third power. What we can do to expand this is we shoot the 3 where? To the front. You remember this from last year, right? So when we do that, what happens with this? This becomes 3 log base 10 of x. And that right there would be my answer as far as expanding goes. Okay? Great question. So if I had something that was, that's actually a really good question. Log base 10 of the square root of x. Okay? What is the square root of x? What's the power of square root of x? Negative 1 would be 1 over x. That's a good thought, though, Kennedy. It's a good thought. It'd be 1/2. 1/2 power. Okay? So it would be log base 10 of x to the 1/2. So what does 1/2 do in our power rule? Yep. So 1/2 goes to the front. Good. So this would be expanded as 1/2 log base 10 of x. And that would be my answer.
What if the x's already have an exponent?
If it already had an exponent, let's say it was to the third here, then you would say 3 times 1/2, which would be 3/2, and then I would shoot 3/2 to the front. Does that make sense there? Okay. Hey, let's see if you could do it together using one. Real quick, someone expand this for me just through words, not through writing down, just through words. Number 25, okay? Emma, what would 25 be expanded, do you know? Is it multiplying, dividing, or is it a power? That's okay. You're good. Paige, you know? It's dividing, good, because there's no and it looks kind of weird a little bit there, but there's no power up on top, right? So because we're dividing 5 over x, how can I break it down and maybe expand that?
Log 5 minus log x.
Good. Log of 5 minus log of x. Okay? We're good on that?
Yeah.
Try this out real quick. Number 3 on the homework, go ahead and try that one out, and then we'll start to go towards the other homework ones, okay? Good work there. And I did, sorry. This is perfect. And then I want to make sure I change 16 to where it's 1 1.
Oh wait. No, that's right. No, it isn't right.
What can I do with L and base E of E? They're the same, right? It would just be 2. So the ln goes with it. So it'd be ln of 6 minus 2. You got it. Or you put the base E, which is absolutely fine. I'll be right there.
Okay. What if I make that? I like it. Is that the same thing? Or do I have to take it off?
What you'll do is you'll take the ln off and when you cancel the ln of e, the ln goes with that. You know what I'm saying? So the ln of 6 minus 2. If you feel pretty good on that, go to the back side, and you'll see the ones at the very top. You should feel pretty good on those. I think it's number 5, I think, on the back side. On those 3, you should be good to kind of start those. And I'll review this if you need it on number 3, okay? I'll be right with you. Good question. So because you have one rule, the logarithms are those 3 rules. So you can do that, and then here's the thing: when you do that, you may bring it to where
But it was like if the question asked,
Did you do 5A?
I think so.
What'd you get?
Log base 6 minus 3 log base 16.
I'm like, you should.
you can actually do either. So that's nice right here. So if I did a change of base, what would the change of base tell me? Yeah. So the change of base, wouldn't that be the ln of? No, that wouldn't work. Let's go to the other one. I'm totally messing with myself. So I would say go ahead to the other one. I thought you could do it the other way too, but I don't want to mess you up. So just go in ln of 6 minus ln of e squared, and then roll in on that side of it. Okay. Good. This x squared minus 1 operates together here. So we're just going to leave that as is.
So like, you don't.
Now, if the whole thing x minus 1 was squared, then you can.
Okay.
Good question. Good. Yes. Good. And then the one you could actually expand that one too. Sorry.
Okay.
You could expand that one too.
Because it's still a 1.
Questions, answers?
I have a pencil and I still don't have like.
I'll be right there. Let me get you. Emma, you got something?
Oh my gosh, that's hard pencil.
I definitely just took it from the art building.
Good question. 9 is the base of my exponent, and 9 is also the base of my log.
I got the power.
Therefore, you can't actually cancel that.
So many.
Does that make sense?
I did juicy stuff all the time. I still miss Runkle. It was so good.
When you canceled out this and you did ln right here, you see this right here? When I divvied it out where it's top minus bottom, ln of 6 would stay the same. What's ln base e of e? Because it's understood e, right? This would cancel just being 2, and then the 2 really, I probably should have shot the 2 in front first, technically, but it canceled anyway. So you would just say ln of 6 minus 2. Okay? Good question. Thomas, do you have something? Yes, I'm going to go over this way. And then I want to go over this way. This one is just a quick thing. Just a quick thing on that. But your overall process looks good. Looks good. Yeah, that looks good. Yes. This one I want to review. We'll review that. And then this one's an expanding one. This one went in the wrong one. Should be an expanding one on that. Elijah, you have something? I'd love to. Yeah, I would love to. Hey, is everyone good on number 3 before I go on to the next section? Y'all good on number 3? On this one right here?
I don't know what we have.
You're good there? Okay. Hey, as we go to number, I'm going to skip this one. I'm going to go to number 5, okay? All right? I'm going to assume that this one on A, you feel Gucci on, okay? If you don't, hey, let me know, okay? On B, this one is a tough one. I saw a couple people mess up just a little bit with this, and I want to make sure we talk through it, okay? First of all, x squared minus 1 operates as one unit because it goes together. Does that make sense? So as we do this, we have the top over the bottom. So how can I divvy these out? Subtracting. Very good. So we would have ln of x squared minus 1 minus ln of x to the third. Is everyone good with that? I like that. Mary Grace was right. But normally, this is what people mess up with. The x squared minus 1 is not squared. So I can't shoot the 2 to the front. You follow me? So because of that, this is actually done. That whole thing. Can't do anything more with it. What about the 3 here?
You can move that to the front.
That's it. Good, Kennedy. The 3 can be moved to the front for that one, making it 3 ln of x on that second one.
Wait,
Okay.
why can't you move to the front?
Yeah, good question. Because of the fact that the squared only is applied to the x, and when you look at the top, x squared minus 1 like goes together. Now, if it did this, x minus 1 squared, that squared could get thrown to the front. Does that make sense? It's a little different. There. So I would just caution you on that, is make sure that if it's together that it's the full thing being squared.
Will we have those formulas?
I actually gave those to you. That's the formulas I said that I give to you because I'm not here, and I want to make sure I set you up for success in that. I'm good. I gave you those right here. I may have only given you the LOG ones, but know that it also applies to LN as well. I mean, other than that. Yeah, Kennedy.
How are we done with it?
That would be it for that one.
What is the greater than 1?
It has to be greater than 1, because if it's not, oh yeah, so great question. Remember when we said that, remember the graph of a log? And ln is no different? The graph of a log looks like this, cuts like this, right? Why does x have to be greater than 1?
The greater process.
Yeah, it can't cross the asymptote, and y'all all said that. That's right. So we would say that it has to be greater than 1 because there's no graph on the left side. Cool? You don't doesn't apply here, but like just know that it's there. Okay? Cool? All right. Elijah asked me to do C, so let's see if we could do this. What do we turn the square root to? 1/2. Good. So this would be ln of x squared over y to the third to the 1/2, right? Okay? What do we do with that 1/2? I like it. Good, Kennedy. So we move the 1/2 to the front, leaving us with 1/2 ln of x squared over y to the third. Okay? Elijah, do you have any thoughts on what we could do to break down x squared and y to the third? Yeah, that's good. And so we would do ln of x squared minus ln of y to the third, right? The only thing I would say be careful on is the 1/2 would be in front of both of those, right? Because you pulled that out first. So when I take this, I'll pull this right down below. This would be equal to 1/2 ln of x squared minus 1/2 ln of y to the third. Cool? One more thing we can do. What is that last thing? Exponents go to the front. You're good? Okay? Good. How do y'all feel on that? Mary Grace? Yep, 2 times 1/2 because it's out there. 3 times 1/2 would be 3/2, and that would be it. It's good. There's one very similar to that on the test. Very, very similar to that on the test. You may want to highlight that, circle it, whatever. You may want to just hold on to that there, okay?
You do 60.
Yeah, so the next one really is going into, by the way, this is weird, I know. One of my hobbies is woodworking. Does anyone woodwork? Yeah? It's so much fun. I know that's really weird. But there's nothing better than like music blaring in my garage and just having, it's fun. It's fun. So that, I don't know, we were talking about logs and it got me thinking about wood. I don't know, it's really weird, I know. But started doing like woodworking. So some of this stuff is like stuff that I've done. All right, so like look at this right here, this is our homework side. By the way, B is an expanding one, so that's still an expanding one. But if I condense it, like A, 6A, what would I do to condense that down? Good. Yeah, Caitlin's right. ln of yt, right? Okay. Now, some of this becomes a little bit more tricky, right? For instance, if you look at D, which was this previous one here, D's a little bit tough, which is kind of the last one on the homework. What do we need to do first before we do anything? The 4's got to go to every part of it, right? Or that's in the parentheses there. So the 4 would go both ways to 4 ln of z plus 4 ln of z plus 5 minus 2 ln of z minus 5, right? All right, thoughts there. Other than Caitlin and Thomas, because they've racked it in today. Someone else have a thought of what we could do? To condense it? Say it again, Josh. I can't cancel it because they're like separate things. Does that make sense? What about the numbers in front, Josh?
4 ln z over z plus 5.
We're multiplying. First, though, what does the 4 do? The exponent rule. Good. It's just the opposite. Does that make sense? So like the 4 would go to the backside. So this would be like ln of z to the 4th. Follow me? Plus ln of z plus 5 to the 4th minus ln of z minus 5 to the 2nd. Good. And what do I do with z to the 4th and z to the 4th and z plus 5 to the 4th? Are we struggling on this one? So we have this right here, right? And z plus 5 to the 4th. Because of the addition symbol, we can multiply. Good. So we would literally have ln of z to the 4th times z plus 5 to the 4th. And then what about this z minus 5 squared? Yeah, there you are. That's going to go on the bottom. Good, Zaria. Z minus 5 to the 2nd. And that would be ln. Everything under ln. That's called condensing. You actually can't. Now, if for some reason this was also a z plus 5, you could. But because it's z minus 5 and z plus 5, they go together, but they're not the same thing. So like z minus 5 is together, and it's not the same thing as z plus 5, so I can't cancel on that part. So we would leave it just like this. Doesn't it make you feel smart, though? Good stuff. Good. Are y'all almost done with y'all's homework? You finished most of it? If you are done, you could go ahead and put it on the left side. Maybe you have 1 or 2 more, and in that case, I can help out if you still are finishing up there. I think we're almost out of here in like 3 minutes. Yes. Actually expanding. Okay, it's in the wrong category. So we take that 1/2 out first. Yes. That's an expanded one. That's my fault. Should expand that one, not condense it. That's exactly. It'll go in this category up to these 3. So that would be like. Does that make sense?
Do we have to do this?
Yeah. So I'd like for you to do this. So just so you're aware, this right here is the equation for a house that's $150,000 at 8% interest rate. Okay. So these are the months, or I'm sorry, these are the years that you can have for mortgage. You got a 30-year mortgage or whatever. These being the length of the mortgage, and based on the length of the mortgage, obviously the less amount of years, the larger the payment, right? So if I have two different monthly payments, right, which is down here, what corresponds to the amount of years on these payments of $1,254 and $1,100? So X represents the monthly payment, and T represents the time. T is equal. So based off a calculator, you're just going to plug in what the total amount per month is into X in the calculator there, and then get out what it would be in terms of interest. Right. Once you do that, I'll help you out with kind of BC and D.
So all that matters though, right?
Does it actually work?
Yeah. Ready, okay? Yeah, this is kind of one of those rules we were talking about. When we make it small. So we've got two logs that have the same base. And because they're added, we can do 1 and 2 and 3. We can actually multiply. So with the log rules, by rule, we cannot, we can't just say, okay, log 2 plus log 32. We can't just say, oh, log 34. Because by rule, it would be 2 times 32 based on the
I hate
Now, I think it's log base 4, right?
Yes.
So when I get log base 4 of, what was the number again when multiply? 364. And I set that equal to X. What do I do with 4 now? Good? Good?
Oh my goodness. It's my math book I never use.
Great, great.
So it's
And then there are 4 X's. Good. Does that make sense? Yeah, what's up, Avery? It was texting last class. I'm not sure. I'll keep it right here just in case. Yes, sir. Yeah, so that's 20 years and that's 30 years. Okay. So now, based on that, if I have 20 years, right? Yes, that'd be good. If I have 20 years, how many months is in 20 years? See y'all. Have a good day. 240, yeah. So 240 months. Okay. Therefore, I have 240 payments, right? I would multiply 240 times whatever my amount is. So if your amount in this case was 1254.68, right? So 1254.68 times 240.
301,000.
See, Elijah? So 301,000. Okay. So think about this. You paid in total on this loan 301,000 for a what house? What?
150,000.
Good. So how much interest did you pay? Ish.
8%.
Okay, 8% interest. But if you have 350, right? For a $150,000 house,
50%.
you paid 350. How much interest did you pay?
Over 100.
Yeah, it'd be extra 200,000.
Oh, I think percent.
Oh yeah, I'm sorry. So total interest amount of money would be 200,000. Gotcha. Isn't that crazy? So this is actually a real number. So a $150,000 home, in reality, you're paying twice over in 20 years in just interest. It's crazy. That's why real estate's huge.
So the other one